Hi, I'm Josh from Seeking English. I teach 3 different types of math tests, or that is, I teach math and verbal on SAT, GRE, and GMAT. And today I want to talk to you about pie-sided polygons. What you need to know about pie-sided polygons is they don't exist. There's no pie-sided polygon. Don't worry about that. So why would I bring it up? The reason I want to bring it up is to talk about polygons more generally. If you are asked on a standardized test to calculate interior angles of polygons, or to do something with calculation from interior angles of polygons, you may be tempted to use memory. You may try to memorize interior angles of polygons. It's probably a bad idea. If you can't tell me offhand what is the interior angle of a 53-sided regular polygon, you don't have much of a chance. A better plan is to just memorize this formula, or an equivalent formula that works like this. You take the number of sides of the polygon. Okay, call that S. Okay, you subtract 2 from that. Okay, take that number, multiply it by 180 degrees, then you divide it by the number of sides in the polygon, and there you go. You try this with polygons that you know already, you'll find it works very easily. You'll just have to trust me, it works for the 53-sided polygon. Here's the thing. If you are taking SAT, GRE, or GMAT, and you're confronted with, this is a plausible problem, I don't know that it exists. Imagine that you are told there's a collection of 1 million polygons, and they have a mean side count of pi. The number of sides, the average number of sides per polygon is pi, or approaching that. And they say, what's the interior angle? What's the mean interior angle? There's no way you can memorize that, or it's unlikely if you're a normal person to memorize that. It's much better to take this formula, put in pi, okay, and you put in pi. And I hope those both look like pi to you. It's a weird angle for me to draw with. And if you run that through your little calculator, because with this problem you should probably use a calculator, you'll find it comes out to about 65 degrees, and in English say some change. Yeah, it's about 65 degrees. And so that's a comparatively simple problem. If you can memorize what I'm describing here, when you're confronted with a similar problem, not an identical problem, a similar problem, you'll have a fighting chance if you realize I need to memorize the formula, or have the formula memorized, and put in those numbers there. Okay, so out of curiosity, what happens if we try to draw something that is continuous as if it were discrete, as to draw a polygon that's doesn't have an integer number of sides? Okay, we'll have a little fun with it here. Okay, it's about 65 degrees. So length of one side is 1. Length of one side is 1. Length of one side is 1, and the other side is length of, okay, approximately 0.14. Each of these is about 65 degrees. Okay, close up. It doesn't work. Okay, but you still need to be able to do it.